What comes to your mind when you pass by huge buildings and other civil engineering structures like bridges and what have you? Just name them. I'm sure you must be thinking of complex mathematics, the integrals, the differentials, the Laplace transforms, and the rest. Yeah, that's part of it, but that's not where it begins. So the topic of today is, where does design begin? Who initiates it? What is it about? What does it entail?
Have you ever just stopped and stared up at a massive skyscraper, or maybe a bridge that just seems to float on air? We're surrounded by these incredible structures, but how do they even happen? How do you go from just an idea to a real-life towering icon of concrete and steel? Well, I'll tell you what, it's not all about the math, not by a long shot. You know, we all have this picture in our heads of what an engineer does, right? Just sitting in a dark room, screens glowing with these insane equations. But is that really where a building is born? In a formula? As it turns out, the real story, the very beginning of it all, starts somewhere much, much more human. This quote just nails it, doesn't it? It kind of blows up the myth that engineering is all about who can do the hardest math problems. The truth is, the real foundation of a great structure is laid way before anyone even thinks about punching numbers into a calculator. It's built on things like communication and curiosity and a little bit of imagination. So, okay, if the whole process doesn't start with a formula, then where does it start?
So, who initiates the design? Where does the design actually begin? For simplicity's sake, I'm going to be discussing this concept using a residential building or an industrial building as an example, because that's the most common structure we have and it's what most of you would likely be able to relate to. So High Chief Edegbu calls Engineer Athanasius if he doesn't have an architect's number. He calls Engineer Athanasius and says, "Oh, engineer, I want to put up a structure, a one-story building for residential purpose or maybe for rentals, whatever he might decide to use it for." Engineer Athanasius say, "Oh, no problem. I'll send you an architect's number so you can do the basic discussions with him on how you want it to be, what the spaces you want downstairs, the size of the spaces, the functions of the spaces you want upstairs, and all of that, and every other thing you want. But in case he doesn't have a structural engineer's number, he's going to call his architect and say, "Oh, architect, I want to build a one-story building. I want a sitting room downstairs that's going to be reserved for family. I want a second sitting room downstairs that's going to be reserved for visitors. I want a visitor's room downstairs, a visitor's toilet, a kitchen, and a laundry downstairs. Then up, I want four bedrooms and another parlor. So those are the things I want for now." And meanwhile, the architect or engineer who is telling these things is busy taking down notes, after which they will probably agree on where to meet for further discussions and site investigation. So they agree on this date, and the architect or engineer, whichever, goes to meet High Chief Edegbu. They go to his site, they check, they look at the size of the plot and compare it with what High Chief Edegbu wants to build and advise further if it's going to be feasible considering the space and every other detail. After getting every detail from High Chief Athanasius, the architect now goes to his drawing board and does rough sketches of various plans that he thinks fits into the client's brief, that satisfies what he understood from what the client told him. Now, this process from when High Chief Athanasius called the architect to where the architect has drafted out a couple of plans to meet the client's brief, it's called conceptual design.
Well, it begins with a whole bunch of human factors and real-world conditions. The engineer's first job isn't to calculate, you see. It's to listen, to understand, and to investigate. Okay, check this out. This is where the story actually begins. Not with a computer, but with a conversation. The client brief, that's the spark. That's everything. Maybe they need a building that can handle hurricanes, or one that's super green. From there, the engineer starts pulling in all this other stuff, their own experience, their imagination. They go out and look at the actual site, they think about the budget, the environment. All of this happens before the heavy math even enters the room. So think about all those inputs we just saw, the client's vision, the site conditions, the money, and imagine pouring them all into a giant funnel. At the top, it's wide open, right? So many possibilities. But as you go down, things get more and more focused. until you're left with one single, incredibly precise plan. And that whole journey, we can break it down into 3 key phases. First up is what we call conceptual design. Honestly, this is the most fun part. This is the blue sky thinking phase, where creativity is absolutely king. The engineer is just playing with all kinds of what-if ideas. What if we made it out of steel? What if we used concrete? What's the smartest, most elegant way to solve this puzzle? It is all about the big picture here. And this quote, wow, it just says it all. At this stage, nobody is worried about the exact thickness of a beam down to the millimeter. It's about using your gut, your experience from past projects to choose the right type of structure. It's about finding the best overall path forward, the one that's going to be safe, economical, and, well, beautiful. Okay, so after all that creative brainstorming, it is time for a little reality check.
After the architect drafted out a couple of solutions which he thinks are suitable enough to meet the client's brief, he reached out to his structural engineer Athanasius. The structural engineer now does a couple of hand calculations that are quite rough to check which of the architect's design are actually feasible enough to be constructed. And from the many options that were brought to him, he streamlines this to a few, most likely one final design. Now this stage is called the preliminary design, where basic checks with basic formulas are carried out to find out which of the proposed ideas are most feasible to construct money-wise, skill availability-wise, resource-wise, and every other factor you could think of.
This is where we get into the preliminary design phase. Here, we take the best, most promising ideas from that conceptual stage, and we put them to the test. The engineer finally starts to run some numbers, some pretty simple calculations, just to see if these grand ideas can actually stand up. Now, this stage is all about iteration. It's a back and forth process. The engineer makes an educated guess on, say, how big a column needs to be. Then they run some quick numbers on it, see how it does, and then they tweak it. It's this constant cycle of propose, test, refine, repeat, until they land on a solution that feels right, one that's efficient and totally doable, without getting lost in the weeds just yet. And now, finally, we get to the part that everyone pictures when they think of engineering. This is detailed design.
And then the last stage, we call it the detailed design stage. So this is when the structural engineer Athanasius has finally decided on which of the proposed options he's going to proceed with. So he has eliminated other options based on reasons such as cost, non-feasibility, and a lot of other factors which he has considered with basic formulas. He has arrived at a particular option which they should proceed with, and he goes on to do detailed analysis where he calculates every load down to the very last kilonewton. Every load that is expected to come on each element of the building. He sizes the beams, sizes the columns, the slabs, designs the roof, designs the environment, and a whole lot of other things to the very last detail. He comes up with the structural drawings which are going to help the site people work on site. And then, but even at this stage, most times, High Chief Athanasius would most likely come and say, oh, maybe as at the point they are still digging the foundation trench, High Chief Athanasius will come and say, oh, engineer, what's that engineer's name? High Chief Edegbo will come and meet Engineer Athanasius and say, engineer, there's no money, but I would like us to add a basement. Engineer takes that down and probably stops his workers from working, because for every adjustment, a good engineer knows that he needs to go back to the drawing board, resize any element that needs resizing based on the new part of the structure, which is going to definitely lead to added loads. He's going to resize elements, change the steel rods if necessary from the drawings before they go back to continue work. Even after doing that resizing and all, when they come back to site, High Chief Edegbo might still come and say, oh, engineer, I know that I said there's no money, and I know initially I told you I wanted to do a one-story building, and then I now came and said I want to add a basement, but I want to still add a penthouse. Look around. If you look around, you see other people are doing a penthouse, and I want to add a penthouse. There's no money, but let's add a penthouse. So engineer Athanasius then stops his workers again and goes back to the drawing board. He needs to resize all the structural elements from the beams, the slabs, from the beams to the columns and the foundations. The slab necessarily do not need any readjustment. You just need to add an extra slab, and the extra slab you add on top is going to result in the resizing of the columns underneath and the foundation in the ground. So this is the detailed design stage. This is what it entails. So if you've not learned anything today, I think you need to go over this video again and watch it from the start. But if you've learned and you need a recap, this is what we've learned today. We've learned that civil engineering design, or particularly structural design, does not begin with Jordan's lemma or Laplace transforms. It begins with a simple phone call from High Chief Edegbo to Engineer Athanasius saying, "Engineer, I want to build a building." They discuss on what he wants to use the building for, and that is called the conceptual design stage. The engineer does basic hand calculations to reduce the number of possible options which were presented by the architect. That is the preliminary design stage. And the final design stage is where the engineer goes into the details to make sure that the final option which was selected is actually possible to be constructed and is going to meet standards which we call the limit state, the ultimate limit state design and the serviceability limit state design. You'll learn more about this in the rest of the video.
This is where the chosen concept gets put under the microscope. Every single force, every connection, every little piece of the puzzle is calculated and specified until that concept becomes a buildable, real-world blueprint. The whole philosophy driving all this detailed work is something called limit state design. Now that sounds super technical, but the idea behind it is actually really simple. It just means a building shouldn't only be safe, it also has to be comfortable and work properly for its entire life. It's not just about asking, will it stand up? It's also asking, will people enjoy using it for the next 50 years? So this limit state design really breaks down into two big categories. The first one is called the ultimate limit state. That's the big one. It's all about safety. Will this thing collapse in a disaster? Is it going to be stable? The second one is the serviceability limit state. This one's all about the user experience. You ever walked across the floor and it felt kind of bouncy and weird? Or seen big, ugly cracks in a wall? That's what serviceability is all about. It's making sure the building isn't just safe, but that it's also a solid, comfortable place to be. So, at the end of all this intense design work, what do you actually get? Well, you get the instruction manual, the recipe. You get a set of incredibly precise drawings for the construction crew. You've got your general arrangement drawings for the overall layout, and then these super detailed reinforcement drawings that literally show the exact size, shape, and position of every single piece of steel in the whole building. So let's just zoom out for a second and put it all together. We've seen this incredible evolution, from a simple conversation all the way to a complete buildable blueprint. Let's take one last look at that whole journey. And there it is, the whole journey. It all starts with that little spark of an idea from the client. Then it gets big and creative in the conceptual phase before it gets focused and tested in the preliminary stage. And finally, it gets sharpened down to a razor's edge in the detail design, ready for the construction crew. You see, it's a process of taking something abstract and making it absolutely concrete. So the next time you're walking down the street and you look up, it's a massive building, or you're driving over a breathtaking bridge, I hope you'll see more than just steel and glass. I hope you'll see the journey of an idea that started with a conversation and ended up as a landmark. You'll be seeing the secret life of the structures that shape our world.